like next week.
The instrument panel of an airplane indicates that the airspeed is 300 kilometers per hour and its compass is heading 35 degrees north of west. So this, north of east, I'm sorry, I read it wrong. This is the trickiest part. Making sure to label your little graph will really help you a lot. So I'm going to draw in a line here that's 300 kilometers per hour long and has an angle of 35 degrees. Okay. And there is a steady 40 kilometer per hour wind blowing from the south. That means it's going directly north. And then I need to find the plane's actual speed and direction. So this is another one where I need to find the vector coordinates for both the airplane and the wind. And when I find it for the airplane, you're going to use the magnitude of the airplane multiplied by the cosine of the angle for the x and the magnitude sine for the y. Okay, so remembering that we always use magnitude times the cosine of x, the theta for our x, and magnitude times the sine of our theta for the y portion here. So I typed these into Desmos to get them. And we got this here is our vector components for the airplane. So I'll draw that part in black. 245.7 and 172.1. Okay. For the airplane, you could do the same thing, but you would use the angle of 90 degrees. So if you went for the wind, I said airplane. If you went for the wind, you would do 40 cosine 90 and 40 sine 90. And I use 90 because that's that angle there. But the cosine of 90 is 0. So here you get 0 and the sine of 90 is 1. So you get 40. And I just like to think about it as where would this point right here be at the top of my vector? It would be 0 over and 40 up. So that's the way that I find those that fall along the axis. So I'm putting both of these here. And now I'm going to do that stack and add thing. So I get 245.7 and 17, nope, that's not right. I think you get 212.1. That's what you would get here. So adding 40 to that, and this is our new vector. And so if I kind of drew this the old way, hopefully have enough room for this, I would take my airplane vector and then tip to tail stack my wind vector, and my new vector would be here. Okay, and that kind of makes sense that it goes over the same distance, but then it goes up a little steeper because it go 245 over and 212 up. Now we need to find how fast this is going, our new one. So that's when I use the distance or Pythagorean theorem, distance formula or Pythagorean theorem, where I square both these and add them together because they are the A and B sides of my right triangle, and the hypotenuse, side C, is my magnitude. And so I have that picture from Desmos. And when I typed that one in Desmos, I got 324.6. So it says find the plane's actual speed and direction. The actual speed of my airplane is 324.6 kilometers per hour. Okay, kilometers per hour. So that my magnitude is the distance, or I'm sorry, the actual speed. The direction then is when you use tan inverse. So I'm going to run out of room. Tangent inverse of y over x. So my y is 212.1, 245.7. And when you do that, I typed that in Desmos. And I got, you can see it right here, I got 40 degrees, 40.8 degrees. Okay, but I need to give the actual direction. So if we're looking at this, and again I'm labeling these north and east, if I start at east and move 40 degrees towards north, I will have my angle. So the final direction is 40.8 degrees north of east. Okay, so that's one part of my answer. And this is my other part of my answer. All right, I'm sorry for this big black spot, but I didn't like the picture that was here, and I had already made a PDF, so I have to kind of deal with it, so maybe I'll try to write on top of it. So a plane travels at an airspeed of 240 miles per hour. I don't want that. With a compass heading southwest. And then we're going to say it encounters a 25 mile per hour wind from the north. Find the magnitude and direction of the plane's actual velocity and direction. Okay, so label your compass here. 240 miles per hour southwest. When you see the words southwest with no like angle, that means exactly 45 degrees. So between south and west, our angle here is 45 degrees. And the distance here is 240. Okay, so I need to do 240 cosine 45 and 240 sine of 45. And then it encounters a 25 mile per hour wind from the north. So that means it's going directly south. Actually, I'm going to draw that going like this. Okay, so it's going directly south at 25 miles per hour. So I'm going to do, I could use the angle 270, so you could do 25 cosine 270 and 25 sine 270. But also, I already know that this is 0 over and 25 down. So 25 down is negative 25 here. Okay, so I'm going to type the 240 cosine 45 and sine 45 in my calculator and get that off of Desmos. And so I just typed this in, and I want you to notice that they're the same. But and that's because on our unit circle, remember, the 45s, like any 45 degree angle, has square root of 2 over 2, square root of 2 over 2. So they are equal to each other. They're the same. But the problem is I used 45, which is a reference angle. And if I were to plot this point over here, I would be going forward and up. And that's not what I'm doing. I'm moving backwards, kind of tracing it in black, and then down. So I need my vector address to reflect that. So I know it's going to be negative and negative. Okay, because I'm moving backwards and down. And to that, I'm going to add 0, comma, negative 25. Not 255, but just 25. Okay, so add those, stack and add. And type this quick in my phone. 169.7 plus 25. I would get negative 194.7. So this is my new vector. And if I did the whole like stack and add thing tip to tail, right, I would be putting my wind vector here, and my new vector would be down here. So it makes sense that it's also negative, negative, because it's forward, or I'm sorry, backwards and down, negative, negative, out in space. Okay, so then to find the magnitude, I have to square these things, but you need to make sure that you square the positive ones. Do not type, I wouldn't even just type in the negatives. Okay, if you're going to type them in, put a parenthesis in, because a lot of mistakes come from typing negative 169.7 squared in your calculator, and your calculator just makes it a negative number, and we don't want that. So to find the new magnitude, we're going to type this in.